Hi and Assalamualaikum. My name is Nurul Muslihah binti Amani Nazri as a project manager from Autonic Engineering Sdn Bhd. And today, my teammate and I will present the proposal of 316 stainless steel. But before we start with the proposal, I would like to show you a short video regarding the Autonic engineering background and my team members.
Hi, good day to my clients. I am Sugeetha Sankaran and I would like to explain about 316L stainless steel. It is known as the most outstanding stainless steel which is used in structural materials in building and civil engineering. The L grades have 0.03% of carbon maximum and are resistant to sensitization in short-term exposures or heat treatments. The 316L stainless steel is a highly corrosion-resistant type of stainless steel as the properties of nickel and molybdenum in high concentration to help prevent surface and piping corrosion. The 316L is very durable and resistant to chemical contaminants and acidic solution such as bromide, sulfuric acid, and chloride. It has excellent formability, therefore it is suitable for Petronas twin tower, which provides a shiny look and a fatigue strength. The desirable properties of 316L stainless steel are to produce high yield strength and tensile strength. Next, the processability of 316L stainless steel contains between 2 to 3% of molybdenum. Therefore, 316L is the superior choice for high corrosion and high temperature application such as Petronas twin tower. Since 316L contains less carbon than 316, it has better intergranular corrosion resistance, meaning it welds but it won't decay. For the next part, I would like to hand over to Farhan. That's all from me. Thank you.
Thank you to Sugeetha. Okay, my name is Farhan Hazizi bin Ghazali. I will present the objective and the problem statement. Okay, first I will present the objective. Okay, the first objective is to understand the possibility of 316L stainless steel and 316L cold roll. Okay, the second objective is to analyze the properties of engineering material based on the structure. The third objective is to determine the stainless steel mechanical properties on Petronas twin tower. And then the problem statement. Okay, the first problem statement is to understand the properties of the selected 316L stainless steel grade. Okay, the second problem statement is to find suitable metal between 316L stainless steel and 316L cold roll that can stand heat and stress for long-term use. The third problem statement is to do the standard procedure of tensile testing. Okay, for the next part, I will pass to the next presenter. That's all from me, and thank you.
Okay, I will share with you our technical finding. 316 stainless steel is a highly corrosion type of stainless steel and has a higher formability. It also has a good heat and chemical resistance. Stainless steel can be a variety of choice that depend on the start of application. After several tests, we had come out with the correct way of testing and the data for the experiments such as stainless strength UTS and yield strength using the right formula. We found out that cold roll method is more effective compared to original. This is our graph. Both of them is tensile strength graph. As you can see at the top, this is our graph for strength vs strength for cold roll. At the below, strength vs strength graph for original. For the next part, I will hand it to our senior engineer. That's all from me. Thank you.
Hello, Assalamualaikum. Before that, I would like thanks to industrial engineer Farmi, and I am Muhammad Firdaus bin Zahari as a senior engineer of our Autonic Engineering Sdn Bhd. I will continue to explain data analysis from the part of technical finding.
As we can see, graph is very related for cold roll 316L stainless steel 1.0 mm and for 316L stainless steel 2.0 mm that is original. We can see at the top for both graph is stress versus strength for tensile strength, and the below graph is for yield strength. The graph is based on the calculation that we have calculated. For the cold roll 316L stainless steel 1.0 mm, the ductility is 1.95%, but for the original is 22.13%. From the graph, we know the cold roll 316L stainless steel 1.0 mm of yield strength and tensile strength is more bigger than original yield strength and tensile strength. So, based on this, we can conclude that the cold rolled 316L stainless steel 1.0mm is more elastic deformation than the original 2.0 specimen. For the next part, we pass to our project manager. So that's all from me. Thank you.
Thank you for Muhammad Firdaus and Abdul Muhammad Farmi. I am Nurul Muslihah will continue to explain about the relationship between microstructure and mechanical performance. So, based on this table that shows the structural modification and fracture length of the first specimen, which is we use 316 stainless steel of original sample and 316 stainless steel of cold roll sample, we can identify which of these two specimens is better. As you can see, the grain size of normal sample is more bigger than the cold roll sample. And for the fracture surface morphology, normal sample have more dark spot or more dimple than the cold roll sample. So based on these two, we can already know that the cold roll sample is more better than the normal sample, because from what I can conclude, the smaller grain size and the lesser dark spot, the higher strength of that specimen. The original length that we use is 25mm, and after the experiment, the final length that we got is 30.53mm, and for the cold roll sample is 25.49mm. And based on this final length, we also can identify which specimen is more ductility and more toughness, because we can just use the formula of elongation. From what I can conclude, the higher the elongation, the higher ductility the specimen is. So for the next part, I will hand it to Harvin Gopianathan, and that's all from me. Thank you.
Hi everyone, my name is Harvin Gopianathan and my metric number is B022110082. So in this presentation, I'm going to conclude this group assignment. In conclusion, with the increasing amount of dislocation density, grain size decreases fairly, increases in material hardness and stability. So if we want to use 316L as in the twin tower application, we have to follow cold rolling to improve its mechanical property. We can use a heat treatment on the body to improve its overall strength in order to improve the resistance to residual stress. So that's all from me. Thank you.